So on worksheet 4, there's some of the questions are going to be common ion questions, and some of them are just going to be regular KSP questions. And how do you tell them apart? I know it's a common ion question if there are two different salts in the same question. And question 2 is a good question where we have two different salts in the same question. We've got lead chloride and we have sodium chloride. Now, when you use your solubility rules, lead chloride is considered an insoluble salt. If you look at solubility rule 3, halogens are usually soluble unless combined with silver, mercury, or lead. So that means we're going to use two-way arrows because we don't know how much dissolves, but it'll only be a small amount. So it's going to break down to give you lead ions, +2 charge, and 2 of the chloride ions, -1 charge. The sodium chloride, maybe I'll change that to red so it doesn't get all confusing, is a very soluble salt. So it breaks down completely, and when something breaks down completely, we use a one-way arrow, and it breaks down entirely into sodium and chloride ions. So your insoluble salt is the one that gets the two-way arrows. Your very soluble salt gets the one-way arrow. The insoluble one will go to equilibrium, so it gets the big 3 steps. So we've got lead chloride breaking down to lead and 2 chlorides. My molar ratio is x to x to 2x, and because this is a common ion question, because we've got two different salts, leave space here before you write the KSP expression. So we've got work to do in this space. KSP expression will be lead's concentration times chloride's concentration, and because of this 2 here, we square it. So this is the math formula we use to solve KSP. Now, if lead chloride was the only thing we had, I would substitute the x's and just do some math, but it's not. We have 2 salts, so we have to do a little bit of considering here. They tell us the molar solubility of the lead chloride. They give us how much dissolves. They give us this value for x. They told us it was 1.6 times 10 to the minus 3. So initially, we're going to have 1.6 times 10 to the minus 3 moles of lead chloride dissolved. That'll give 1.6 times 10 to the minus 3 moles of lead, and twice as much, 3.2 times 10 to the minus 3 moles of chloride. That's the initial amount. But at the same time, we've got sodium chloride in there, and there is 0.1 moles per liter of sodium chloride. And since all of it breaks down, this value will be 0.1, and this value is 0.1. It's a 1-to-1-to-1 ratio. So what we want to pay attention to then is the ion in common. So we've got chlorines here and there. So the change, C for change, that happens to this equilibrium is in addition to the chlorine from the lead chloride, I'm going to add 0.1 moles per liter from the sodium chloride. The net effect of that at equilibrium is that the amount of lead is going to be reasonably the same. We never added anything there. But the amount of chlorine is the sum of those. So we're going to get about 0.1. Now, if you add it up, you're actually going to get 0.1032. And this is reasonably close. We could actually use that whole number, but more often than not, if these numbers are within 2 decimal points or more than 2 decimal points away from each other, significant figures rounds it right back out anyway. So essentially, all of the chloride ion came from the sodium chloride. Now we're going to put these values inside the brackets. So, using the math formula that I've calculated, the concentration of lead is 1.6 times 10 to the minus 3. The concentration of the chloride is going to be about 0.1. You can see it was 0.1032, but there's really only 2 significant digits there anyway, so it's about 0.1 squared. So we've got some math to do, folks. Square this value first, then multiply it to get the KSP. Gives us a value of 1.6 times 10 to the minus 5. So when we have a common ion question, I know it's common ion because there's 2 salts. One of them is insoluble. It gets the big 3 steps. The other one is going to be very soluble, and it breaks down completely. The other clue about which one gets the big 3 steps, if you don't have your solubility rules handy, is they'll ask for a KSP or give you a KSP for that particular salt. Okay. So there's a couple of clues about which one gets the big 3 steps, because we can't do a KSP, an equilibrium expression, unless the reaction can hit equilibrium, and sodium chloride can't. It's a one-way reaction. It's not going to back up again.